Okay. Now, let's take a very simple example, okay, from the bank data set, and we're going to use only one predictor so that we can understand the concepts, right? So our model L is intercept plus the slope coefficient times x, where x is your income. Okay. Now, we want b sub 0 and b sub 1 value. This is what we are trying to figure out. Once we have that figured out, then we can use it in our computations, right? So we need to set up, so right now we have nothing here, okay, but if you have some numbers, okay, so like say -1 and 0.1 or something like that, okay, we don't know what the best values are. That's what we're trying to figure out, okay. Now we can set up for a given b sub 0 and b sub 1, we can set up this maximum likelihood function. So L will be what? Okay. B sub 0, okay, we have to absolute reference that, plus b sub 1, absolute reference that, times the x value. So these numbers that we are using now is just a trial value. Okay. We want the best possible value here. Okay. So if these are the values, that's what L is going to be, b sub 0 plus b sub 1 x, right? So then we can compute from L e to the power of minus L. Then our probability P is going to be 1 over 1 plus that. Okay. So 1 over 1 plus e to the power of minus L. So we did L, then we computed e to the power of minus L, then we have 1 over 1 plus e to the power of minus L. That's our y hat, or that's the P of y. Okay. Yeah.
For the e to the power of L, did you use exp? Like,
yeah.
So I get a different answer.
Okay. Okay, if you use b sub 0 and b sub 1 the same, then it should be the same.
Actually, yeah, it was the decimal, it's just the decimal places.
Okay. So now we can set up the likelihood function. Okay, so that's our p sub y. So if you do p sub y, okay, so to the power of y, okay, times 1 minus p sub y to the power of 1 minus the actual target, 1 minus y. Okay. So this function, whenever personal loan is 0, what you will have here is probability of 0. Whenever you have personal loan of 1, that function will turn out to be the probability of 1. Okay. So this will be like that. Well, I need to copy the whole thing. Okay. So here, this is probability that this is equal to 1. Okay. And for the rest of them, these are all probability of 0. Okay. So now we copy this whole thing. Now we need to do a logarithm, so that will be ln of that. Okay. I'll copy that everywhere. So then you sum. So you have this. So that's our likelihood function. Okay. All of that. So that's our sum of the logarithms. Okay. So our estimation problem, which is called the maximum likelihood estimation, is that, so this is the probability of all of those target values. Okay. So we want b sub 0 and b sub 1 estimated in such a way that this likelihood is maximized. That's why it's called maximum likelihood estimate. So how can we do that? Well, there are lots of procedures for doing this. In Excel, you can use solver. Okay, so there is no solver here. So let me make sure that this. I have to go on add-ins. Okay, Excel add-ins. I have to check solver. Okay, so once you have solver checked, I can go to solver, and we want to maximize C16. Okay, well, it's already set up here by changing cells b sub 0 and b sub 1. Okay, and we have to make sure that we select GRG nonlinear, because it's a nonlinear problem, because the sum here, the objective function, is a sum of logarithms, and that's not linear. Okay, so then solve, and now you have an estimate for b sub 0 and b sub 1. Okay, and this is the maximum possible value for the logarithm of all of those. Okay, and here now you will see that this column, all of them is as close to 1 as could be. Okay, for each observation. So our L now is what? Minus 6.1273 plus 0.0371 times income. That's our estimate. Okay. Maximum likelihood estimate. That's our model, logistic regression model.